Ever wondered about those mysterious mounds of dirt in your yard? They're more than just dirt. They're the bustling, strategic cities of one of nature's most organized creatures. Ants. We often see ants as tiny nuisances, but their engineering prowess is incredible. Today, we're diving deep into the why behind their most iconic creation. The anthill. Think about it. Why build such elaborate structures when they could just live under a rock? It's not just for shelter. It's a matter of survival, efficiency, and social complexity. At its core, an anthill is a fortress. It protects the colony from predators like birds and larger insects, and shields them from harsh weather conditions, be it scorching sun or heavy rain. Anthills are brilliant climate control systems. Their intricate tunnel networks help regulate temperature and humidity, creating stable conditions essential for the colony's well-being. Specific chambers within the anthill serve vital functions. Deeper, more humid chambers are nurseries for eggs and larvae, while others are meticulously organized pantries for food storage. Beyond protection, the very design of an anthill can be a defensive weapon. Multiple entrances confuse predators, and narrow tunnels create choke points. What's fascinating is there's no single architect. Ants build through self-organization, following simple rules and responding to local cues. It's emergent intelligence in action. Pheromones play a crucial role. Ants use chemical signals to communicate where to build, where to find food, and even to mark danger zones within the nest. How do they dig? Ants use their mandibles to pick up soil particles and then carry them to the surface, depositing them at the entrance. Millions of tiny movements create the mound. Not all anthills look the same. Their shapes vary based on species, soil type, and climate. Some are towering cones, others are flat and spread out, each optimized for its environment. Take fire ants, for example. Their large dome-shaped mounds are designed to withstand floods and regulate temperature in hot, humid climates. They're engineering marvels. Leafcutter ants build vast, subterranean nests that can house millions. These aren't just homes. They're underground farms where they cultivate fungus from leaves for food. Some ant species form super colonies, where multiple anthills are connected by underground tunnels, creating a sprawling network of interconnected cities. Anthills aren't just defensive structures. They're strategic bases for foraging. Central location means less travel time to food sources, maximizing energy efficiency for the colony. Ants are meticulous about hygiene. They often designate specific chambers as refuse piles or middens, keeping the main living areas clean and disease-free. Smart, right? Many anthills feature elaborate ventilation systems. Tunnels and shafts help draw in fresh air and expel stale air, crucial for the health of the dense colony. As a colony grows, so does its anthill. New chambers and tunnels are continually excavated, adapting the structure to meet the increasing needs of the population. Next time you see an anthill, don't just walk past. Take a moment. Observe the ants, their industry, and the intricate details of their construction. It's a living lesson in nature's engineering. Remember, these are vital homes. Avoid disturbing anthills. Appreciate them from a distance. They're doing important work for their ecosystem. What can we learn? The power of collaboration, self-organization, and adapting to environmental challenges. Ants solve complex problems with simple collective rules. So, anthills are multifunctional marvels. Homes, nurseries, food storage, climate control, and fortresses, all built by tiny cooperative engineers following simple rules. The next time you see an anthill, remember, it's not just a pile of dirt. It's a testament to nature's incredible design, built brick by tiny brick, by the humble ant.